Okay, welcome back. So now we're going to deal with the last part of this sequence of videos showing you how to set up the APoLUS model from scratch. And we've gone through step by step in the switchboard. We've set everything up from our study area to our land use maps. We've set some actor characteristics. We've set neighborhood rules. We've set accessibility. So roads, electricity networks and so on. We've set suitability and we've set our zoning rules, so our institutional restrictions. Okay, so now we're ready to run the land use model. Okay, so as we did before, you go back to where we had APoLUS stored, and here we've got all our different our data folders where we've been storing our workspace. Okay, so we're going to open this back up again in our studio. This is the last one. In the last video we dealt with the zoning, so that's the last part of the APoLUS model, the last block that needs to be set in the APoLUS model. Just going to load that in. Okay, and there, remember, so we also need to bring all our maps back in. So just one more reminder. Okay, so this script, we're just going to run that, and what that actually does is that just imports. So as we've been going through the model blocks and creating, so all the maps necessary to run the model are stored there in this file. Okay, so we should have those all there, and they'll be imported when we run that script. Okay, so now we need to bring back up the main switchboard, which is switch B .r. Okay, so it's going to load in all the different packages we need. I'm going to make that full screen, and then there's the sequence that we've run all the way through. Okay, those models, those different, bringing in those different maps and setting those different model parameters. So we've imported the regions, our starting land use maps, we've set our categories, we've set the actor characteristics, calibrated the neighborhood, we've given them some very, very simple neighborhood settings just to start. We've done accessibility, suitability, zoning. Okay, now we're ready to run. Okay, so let's just click there on number 8, run model, and that brings up this other dialog, okay, which is the simulation control dialog. Okay, so here, these two calibration scenario, this is currently doesn't make any difference which one of these you choose. They don't actually. That's just a placeholder there for something I was going to do. Haven't quite got around to yet. Doesn't make any difference what you do there. But the key thing here is you've got the different model blocks. Okay, so this is neighborhood, and V is the random factor. This is neighborhood and randomness. This is neighborhood accessibility and randomness. Neighborhood suitability and randomness. Neighborhood accessibility, suitability and randomness, neighborhood accessibility, suitability, zoning and randomness. And this is the last one that we're going to use because we've set up all of these different factors. We want to use all these different factors in our model. This is the actor dynamics, the neighborhood rules, accessibility, suitability, zoning, and of course that stochastic factor, that randomness, right? So we can scale the stochastic factor. If we put a higher number here, so 0.9, we basically get more randomness. Okay, so this is not, you can choose whatever number you like. Choose 2, 3, 4, 5, 10. Obviously, if you choose numbers that are, I would say, numbers higher than 0.5 are going to give you a lot of randomness. Numbers lower than 0.5 are going to get you closer and closer to a very deterministic model. So you're only going to get the results of these rules. Okay, so our start year and end year are already set, of course, because that's what we set early on at the beginning. We've already got that, and the only thing we need to do to run this, so what we're going to do now is we're going to run it from the year 2000, our start year, our initial map, through to the year 2007. That's our second land use map. Okay, and we're going to try and produce a simulation of that second land use map to compare, to see how well we've calibrated our model. So at that point we need to set our land use claims for our end year. Okay, and it's then going to ask us to set our claims, our land use total demands for those years, and it's helpfully giving us the land use tables here. And so this is fantastic because we're working at starting from 2000. Okay, demand 2000. That's the current demand we've got, and we want to go through to 2007. So we just literally need to do nothing more complicated than just put these numbers directly in here. Solar 84. Okay, so this is exactly the amount of land use for each of these categories in this map in 2007. So we're doing nothing more here than just replicating the 2007 map with the rules that we've set as we've gone along. Okay, and so those are the three, you see marked here with A, the three active land use maps, one of which, solar, is influenced by the active behaviour that we set. Okay, so there we go, that's done, and it reminds us that we need to return to the dialog, and nothing happens here until we press submit. Okay, so every time we set something, we change something there, we need to press submit, because now we're going to submit. Okay, so this is where it has a look at the maps, and it realises that actually the two maps don't have the same number of categories, and this is simply because in the first map in 2000 there was no solar energy installed at all. So that's no wind energy. There was no wind energy there at all. So that is number 5. Okay, that's that category number 5, and that's the missing category. Yeah, and there's no other missing categories, just 999 to exit. Right, so then now it's saying the tendencies file exists. So tendencies file, this is explained in the user guide. This is a tendencies file that actually just simply controls the way that the different land uses grow. It's just a simple CSV file with a tendency value that controls incremental value. But this is explained in the user guide. I'm not going to go into that now. But we also do have final claims, and the model said final claims, obviously, because we've literally just set them. So it says, do you want to use the tendencies file? And we say, no, we want to use the claims that we've already just set, right? And there it is. It's given us them. It's calculated everything correctly. Okay, and it's given us there our land use category 3, which remember is urban, 7416. Our solar is category 84, and our wind is 117, right? So it's going to grow there from 0 in 2000 to 117 hectares. Sorry, not hectares, cells. So these are 200 by 200 meter cells, so each cell is 4 hectares. Okay, so 117 200 meter resolution cells is what's going to grow there in that case, in the case of those the wind. Okay, it's giving us a little bit of information. It's telling us actually there what the demands are, the annual demands are. Okay, in fact it's telling us there, look, the starting demand that we already had before. Yeah, okay, it's giving us all the information. The actors we haven't allowed them to influence the claims, because of course you could have in here, we did at one point think it might be useful to have in here the actor negotiations actually control the amount of land that can be allocated. That makes sense. It isn't set up like that at the moment. They just simply control where that land is allocated, as we'll see when we run this simulation. Okay, let's just go and run simulation. There we go. Okay, and that's gonna run through nicely, telling us what it's doing at each stage. It's quite quick. It's not a we haven't got a very large study area. The cell resolution is relatively coarse, 200 meters. Okay, and there we go. It's given us a null there because it's not found a GIF image magic on the system to create an animated GIF. So there is our result, and we can just go hit return. Okay, and there we can see how our simulations worked out. So if we just remind ourselves, okay, so our last map is always TN. Okay, so we've got our frequency for that. We can just check if everything's worked out okay. Remember, we were sending this to, we've set these land claims up to allocate the amount of demand, or the amount of land claims exactly equivalent to the ones that we had in the 2007 map. So our TN, this is our final simulation map for the year 2007. It should obviously match land use 2, which is the real year 2007. So we're just going to check, and we can see that yes, it does. When I say should match exactly, what I mean, of course, is that the allocated land should match exactly, right? Remember, we're not allocating layer 1, which is natural, or layer 2, which is agricultural. Those are passive classes, but our active classes is urban, which is 7416, solar, which is 84, and wind 117, and it has indeed allocated those exactly correctly, as it should do. If you can't remember which land use is which, you can just bring up the land use table and it'll remind you. Okay, so yeah, we can see that's the way we check that everything's worked. Not only we can see on the map that it's worked, but also we can see that you can see in the tables that actually the correct amount of land use change has indeed been allocated, so everything there is worked out as it should do. So one thing that you can see here, of course, is that just a little, you know, just a visual inspection, nothing more. You can see that there's a lot more urban land, which is that dark red colour. And then that's been allocated. You can see it's in a linear fashion, so it's obviously following those accessibility settings we added. But of course, we've got almost none in the north, very little in the north, which is normal, because remember we set our zoning to say we wouldn't have much urban development there. That wasn't encouraged, and that obviously has meant that because there's been no new development over those years in our model in the north, then all that development expressed by this demand, this total 7416, it's gone from 6176 to 7416. Okay, so you know, something like 500 odd cells of new urban land. All those cells of new urban land have gone in the south there, where we had the highest suitability. We set our neighbourhood rules for adjacent cells adjacent to existing urban land to be the most favoured, and indeed that's happened. That's why we get these clumped up areas. So of course, what probably did happen in reality, and we can look at that now, is that most of that growth that occurred during that period was around the capital Pamplona, which is we've got there in the centre of the map. So perhaps this is not a very realistic simulation, but this shows basically how the model works. And one thing you notice, you've got this yellow blob there, and that of course is because all our solar, if you remember, let's just have a look at actor maps TTPs, okay, and that's because we had this very high value. All our actors were very motivated towards solar installations in this municipality here, right? And that, of course, is why we have why all the solar, although there's not very much of it, why all of that there. So it's an important increase, right? It's gone from just one cell there, one 4 hectare cell, to 84 4 hectare cells. So those additional 83 4 hectare cells, they've all gone to that location. So we can see how the actors have attracted that solar into that location. Okay, so I'm going to stop that video there. Okay, thank you. See you next time.